I guess I have two questions. The first question is, it seems like most of the research that has been done focuses on after the fact, or the incident response, meaning that once you have the code, then you probably already knew it was some kind of malicious code once you get to that point, if you're going to check if it's malicious or not.
Yeah.
Now, if you want to make it dynamic, how can you make it dynamic so that you can detect whether it's malicious code or not? I guess that's the first question.
Yeah.
And the second question is, has there been any data sets in which, so the big example I would use is SendMail.
Yes.
SendMail, at some point, everyone was using it, but they did not know that there was malicious code inside of it.
Yeah.
So has there been any huge data sets or any huge source code data sets that might have included some kind of malicious code to see whether the algorithms used can detect some, like a small amount of malicious code in a large amount of code that's not malicious at all?
Okay. So the second question, the first question is, we are looking at things in terms of detection, but not in terms of prevention. Okay, or ahead of time, before the attack happens. Okay. So prevention. I mean, much of the work, research actually has focused on the intrusion detection. Right. There has been some work on prevention, and the prevention part also, again, some of the things like honeypots, I think, although I call it offensive, would be more the prevention, because we want to set up these things to find out who are the people who are flocking into our systems. Okay, so that could be considered to be a prevention. So in terms of what we are planning to do for prevention, the runtime analysis, so when the program is running, but we haven't developed, we are having some discussions, but unfortunately we don't have any solutions yet for the prevention. And there is some work, but again, many people, because again, the detection part is far less complicated than the prevention part. Okay, so now prevention with the honeypots and maybe looking at the runtime analysis, hopefully maybe if I come next year for a talk, I might be able to discuss on the prevention. The second one, I think that we have in the parts that I didn't discuss, we may have some answer to that question. Looking at the email features, does the email have HTML signatures, tags, and so on? So your question then is, in terms of the data sets, are there huge data sets where a small amount is the malicious, right, and the rest is not malicious?
Well, like, for example, the source code for SendMail, when it was released so that it could be installed, for the purpose of email, or think of it as any other application. It was a normal application that anyone uses it, but it actually had malicious code inside of it. So attackers were able to use it without people knowing that it did have malicious code in it.
Okay.
So I didn't know whether anywhere in there you tried to figure out whether you can find an anomaly in sort of a normal, a normal data set that might have some sort of small malicious code that can have a large impact.
Okay. So if this system should work on doing the email analysis, which I didn't mention, looking at all of the outgoing emails and extracting features, if this malicious code is a feature that we have extracted, then this particular technique, which I did not talk about, should work. Okay, but what I don't want to mislead you and say we have, because what I think it should, because what we have, but whether the test data has, whether it works for a small amount of malicious code in a huge piece of mass of data or code, that part I don't know. But it does, this particular technique, which I did not mention, which is our PAKDD paper, it's a feature-based techniques for auto-detection of novel email worms. Okay, that's our first paper. So it should work, but I cannot sort of confirm for sure. Chris, do you have a question?
Yeah, quick question on this. The environment you're looking at, where you're dealing with coalition partners, would seem to me that it's a constrained environment to begin with. You have a limited number of partners and a limited number of things they're supposed to be doing.
Yes.
Does that help the problem in terms of kind of if someone's doing something malicious, it's rather than hiding it in general traffic, they're hiding it in a more specific set of traffic. Is that something you've taken into account in your experiments?
Okay, so that's a very good question. Okay, so the question is, right, we are saying we are doing this in the context of assured information sharing. But I have to really sort of confess something. Okay, so the thing is, okay, while we are looking at trustworthy, untrustworthy, when it comes to this, I think what is happening is that we are doing the research and trying to bring this into this environment, rather than looking at this environment and then trying to develop techniques to fit into this. Okay, so it's a little bit not a little misleading when I say that this is really defensive operations and assured information sharing, when really the focus is on this research, looking at data mining. So let's look at this environment. So what we are trying to say, we have an untrustworthy partner. What this partner might be doing is, good question, partner might be doing is putting some sort of virus and worms and so on. So here we have these techniques that will maybe detect whether our partner, because our assumption is that we are connected in this environment, in this coalition environment is where the malicious code is coming from. But what we should also do is from which untrustworthy partner it's coming. So you're right, you can ask a question, these techniques can work in any untrustworthy environment, but not just in a coalition environment. So I think what we should do, and that's a good point, is to get this into the coalition, try to figure out from where this piece of malicious code is coming. So you're right, when I say that this is, it's also the interest of the students too, right? It's trying to, develop, the student is very interested in developing all these tools and techniques, and somehow or other I am more interested in bringing into this environment, so something that we will be doing. Okay, that's a very good point, Chris. So I have a question to, you are the experts in privacy, if you don't mind, and that's when I said that the government says, when I teach these classes, that privacy, okay, again, we are discussing privacy within this context of data mining, right? So when it comes to privacy, the whole idea of privacy preserving data mining and so on is of little use because the government already has the data. The fact that you are having AIDS or you are 50 years old or whatever is not going to, we cannot hide that. So the whole idea of privacy preserving data mining is to keep the data, right, the original data, and perturb, randomize, whatever, and apply these techniques.
That's one approach.
Yes.
Another approach, which more of the work here follows the second approach, is that ties into this coalition environment. The idea is, rather than directly sharing the data within the coalition, you collaboratively compute to compute the data mining results. So even within relatively trusted partners, it saves you from, you have certain information, another partner has certain information. You don't have to give that data to anybody to do that. You can still get results that come out of combining the data.
The whole idea, so I think the cryptographic checksum method, multi-party computation,
is
probably the way to go in this environment. Right? You don't give out the data, but end result, they all have to work together in order to solve this problem, and so the end result is given. So that really makes sense. Okay, so this is sort of the biggest challenge, and then you all are doing a lot of work in this too. Arif? Arif is also a question, right? Arif and then Arif. Yeah.
Confidentiality, if I'm not mistaken, providing access to the information to your partner based on the content.
Could be content,
based on the context.
Based on context as well, confidentiality.
So suppose I probably can view it as a content-based and context-driven control mechanism in which content ought to be filtered.
Okay.
And depending on the context in which you are trying to provide access to.
Okay. So the whole thing, we can have a lot of discussions on confidentiality, privacy, and